Hey guys, it's Ben here at CARATUNK Contractors LLC. We're an excavation company serving New Hampshire and York County, Maine, up here in New England. Licensed and insured in excavation and septic systems here in the state of New Hampshire. Most of what I'll be talking about today is generally informative for homeowners in New Hampshire. Most of this applies to the rest of the United States septic system trade, but states vary state by state. We all do a little different systems. We have different inspection and regulations depending on our counties or our towns or our states that we're in. Some states are unlicensed, some are very strict. New Hampshire's is very common sense, it's very in the middle. Actually love being an installer in New Hampshire. But lately, coming across a lot of customers we deal with, getting a lot of questions of what is a septic design? Why do I need a septic design? It's a little bit of pushback just because of our customers don't know, they've never seen a plan before. They don't know what goes into it. So I'm here to kind of help out and ease that with future customers and kind of open up homeowners to what's going on in their septic plan and how it can help them down the line. Because not a lot of information out there on what goes into these, so I'll be answering that today. First off, go into an example here of a system I installed in Newmarket, New Hampshire. What is a septic plan? A septic plan is essentially a site plan drawn by a septic designer or a civil engineer in New Hampshire, displaying the lot lines. So these are the boundaries of your property. The existing conditions of the lot, whether you have a house or you are building a house, there's still going to be existing conditions on every lot, whether it's your contours or a rock wall, or if there's trees over here in the corner, which there were on the system, or if you have a chicken coop, paved driveway, where the street is, that's kind of all on a plan. Proposed segments will also go onto your plan. So on this system, we just replaced the septic system. There's no installation of a well or anything of that nature. So this was all existing right here. Existing decks, existing house, existing driveway. But on some plans, you will see a proposed well or a proposed addition on a house, or a proposed added driveway. Stuff of that nature will end up on your plan. And of course, the septic system is on your design. So it has the different components. You have your sewer line running out of your house and meeting your septic tank. So right here is your septic tank. From your septic tank, you have settlement, and out it flows the effluent to your system. The basic system in New Hampshire is stone and pipe. It has a D-box in the middle, and it runs to perforated pipe, and it settles into the ground. You'll also see on your plan the stamp from the designer, the installation company, a scale, a legend. This helps you read where the test pit is, percolation test, water shut off. You'll see the approval from the state of New Hampshire, a compass with your northing, cut section from the side, test pit and its data, a location, owner information, tax lot, stuff of that nature, and your leach bed requirements, design intent, and general notes. So the next question we've been hearing a lot of is, why do I need a septic design? First and foremost, anytime a system is installed or a leach field is replaced in the state of New Hampshire, a design and approval is necessary. This is a regulated trade within the state of New Hampshire, with installers taking a rigorous 4-hour test and designers taking multiple rigorous tests to complete and secure their licensing/permitting with the state of New Hampshire. This is regulated by the New Hampshire Department of Environmental Science. The state wants to regulate these systems to ensure clean water and land. A poorly installed system can get people sick, ruin well water, and add disease/bacteria to our state's lake, rivers, and oceans. Nobody wants kids getting sick swimming in their lakes. Nobody wants to get sick having a glass of water out of the tap. That's why we're here. Plumbers and septic installers are at the forefront of keeping our communities healthy, and we take that seriously. I seriously believe, keeping bacteria, separating your well water from your septic system is important. We'll get into all that and how that comes into a design, but that's where we're coming from. That's how a lot of the guys we work with, our competition, ourselves, people in the industry, that's how we feel about it. So that's why. Another question we ask here all the time is, what goes into a design? And why does that piece have to go there? Why do I have to have a tank right here is a question I hear all the time from customers. And it's a valid one. So getting into this, essentially these designs are a giant puzzle. The puzzle starts with its boundaries. For example, this puzzle is roughly 227 feet long by 100 feet. So boom, you have the limits of the puzzle. Now, sticking with the puzzle concept, let's start dropping in some of the existing conditions. On this, we have a house, we've got some decks, we have a paved driveway, we have a well with a water line, we have chicken coop, a shed, we have a hill. This is kind of relatively flat area, and as you can tell with the contours, got a slope. So that's part of the story here. We got trees. With all these existing conditions, the state spec plays a role. So everything on the plan is kind of formulated in offsets and sizing by the state spec from DES. So if you go to the spec, you got about 130 pages of everything and anything that has to do with our line of work, including offsets. So here in the spec, you can see they have offsets of how far your septic tank and your leach field and your sewer line have to be from lake water, property lines, catch basin, you name it, a reservoir. It's in here. Your foundation. So going back to this, all of a sudden all your puzzle pieces have offsets. And you can't put the components of your septic system within these pieces. And now the puzzle's kind of shrinking, and you can only fit these different pieces in different places. Now it's kind of shaping up. The next part of the spec is the size of your system. And sizing these puzzle pieces, essentially, like your septic tank. In the state of New Hampshire, 1 bedroom through 4 bedroom is a 1,250 gallon tank. And then for every bedroom you add after 4 bedrooms, it's an additional 250 gallon tank. 250 gallons to the overall tank size. So for this example, we're going to 3 bedroom house. We're in the minimum size. It's precast 1,250 gallon tank. So we got the size of that puzzle piece. Same thing goes for commercial. In the spec, they have a sizing chart on your size tank needed depending on what your usage is. Same goes for the leach field. The leach field's a little two-pronged. So first, you want to calculate your flow rate. The flow rate is calculated in the spec based on your intended use and how large that intended use is. So if we go over here, for residential, they have on this table here the flow rates needed for a 2 bedroom house, a 3 bedroom house, a 4 bedroom house, and in each additional bedroom past a 4 bedroom house. They also have a table for how many gallons per day in a commercial use. Commercial uses are found in a different table within the spec. They have everything in here. Country clubs, dentists, factories, fire stations, gyms, laundromats, motels, and these are based off of the number of employees you're going to have, the number of seats at your restaurant, the number of machines in your laundromat, how many doctors, how many kennels for your dog kennel. Everything's in here. You figure out what your usage is commercially, how many seats you're going to have or what have you for the scenario, and you can calculate your flow rate per day. That allows you to go back to the sizing and you can figure out this top part of your chart. Let's hold on here. Do a quick highlight. Got 3 gallon, 3 bedroom, 450 gallon per day. Hold that thought. Back on the plan, in the corner here, we have our test pit data. Test pit data is going to take a look at the soil type. It's also going to take a look to see if there's refusal. Are you going to hit bedrock? You're going to look at your seasonal high water table. Do you see any water when you observed? Is there a restrictive layer that you came in contact with? Part of the test pit also is performing a percolation test. Percolation rate is figured after saturating the bottom of the test pit. So you're going to dig this hole about 4 feet deep. Depends on the system, generally speaking. You go a few feet down, you saturate the ground for an extended period of time per the spec, and then you then fill up the hole again and you calculate how long does it take for the water to dissipate. In measuring that, in simplest terms, you figure out your percolation rate. So on this particular system we did, the percolation rate was 1 inch. It dissipated 1 inch per 8 minutes. And you get this info right here. Percolation test. We know our use. We know the size of our use. 3-bedroom. That's our flow rate right there, 450. We know it's 8. We're coming down to 750 square feet is the size of our leach field. So we just figured out the size of another puzzle piece within our septic system. 750 square feet. So let's go back to the plan here. You can see the math the designer performs. They lay it all right out for New Hampshire DES to take a look at. And they decided to size the 750 by going 25 by 30 for the field build. So now that here's the size, becomes where can we fit it with the existing conditions? And this designer picked the right spot. Some of the things he was thinking about were, he didn't want to put it in the side of the hill and have to truck in too much fill and cost the customer a ton of money. He didn't want to put it in the way of the shed. He didn't want to be within any of the offsets. He didn't want to put it over here in the trees and have us cut down a bunch of trees and cost the customer more money. We want to do this efficiently and effectively. So he put it right here. It's a good spot. Minimal fill. You can see that contour line right there is minimal fill. And that's another puzzle piece, sized and fitted. So now that we kind of have all the puzzle pieces left, right, up, down, there's another side to this puzzle, and that is elevation. Everything here has an elevation. And going back to this test pit data, we observed the seasonal high water table. In this case, we didn't observe one, but in the state of New Hampshire, there is a difference between the seasonal high water table and the bottom of your system they want to see. They want to see the effluent, for simplest terms, filtered out before it gets to your well water or your water table. They want that separation for the bacteria to do its work naturally, in simplest terms. So going back to the spec, take a look here. It's a very important piece. And generally speaking, the bottom of an effluent disposal area, EDA, shall be at least 4 feet above the seasonal high water table. Very important piece. Once again, going back to health and safety, you want this separation. So another thing designers have to work out is if they have a seasonal high water table right here and they go 4 feet up, that's the bottom of their system. Do they have the rise and run to go back and hit the plumbing within your house? Do they need to change the elevation on the footings for the proposed house to make this match? Kind of the things they have to start thinking about. If it doesn't make sense, let's say the seasonal water table is up here, that means the bottom of your system's up here. Let's go gray here. Boom, that system's up here all of a sudden. Well, given the state spec slopes that we expect to see in our pipes going from the existing house to meeting this is just not going to work. So in the state of New Hampshire, how we solve that is we put a pump. And we pump it up, and that's just another scenario of a puzzle piece, making it fit within the code, within the existing conditions. That's what our designers are doing every day, and our installers are bringing to completion out here in the field.